Okay, so in section 5.7 we're going to talk about inequalities in two triangles instead of just within the same triangle. So we're going to be comparing. So theorem 5-13 is called the hinge theorem or the side angle side inequality theorem. If two sides of one triangle are congruent to two sides of another triangle and the included angles are not congruent, then the longer third side is opposite the larger included angle. So let's talk about this. So go ahead and make sure you've copied that down. Don't forget to pause the video so that you can get everything down that you need to write. So I have two triangles where AC is congruent with XY, AB is congruent with XZ. The angle included in those two sides is angle A and angle X. Now in this case, we are going to say that angle A is smaller. Actually, it looks bigger, doesn't it? That angle A is larger than angle X. Since the two adjacent sides are equivalent and A is bigger than X, we now know that side CB, because it's opposite the larger angle, is larger than side YZ. Okay, so two different triangles, congruent pairs of sides with an angle in between them that is a different size, and we can then tell which triangle has the larger third side. Okay. Oops, so here I've got it written down already. If measure of angle A is larger than measure of angle X, then AB, that should have said CB, then CB is larger than YZ. Okay? Theorem 5.14, the converse. So now, same thing, if two sides of one triangle are congruent to two sides of another, and the third sides are not congruent, then the larger included angle is opposite the larger third side. So this time, if we know that which side is longer, in other words, if A, again, that should have been CB, if side CB is greater than side YZ, then we know that measure angle A is greater than measure angle X. So sometimes you'll know the measure of the missing side, sometimes you'll know the measure of the missing angle, but either way we can tell which side or angle that corresponds is going to be the larger of the two. It's called the hinge theorem because if you think of something that has a hinge or a joint, and the example that the book uses is a pair of scissors. So if I have a pair of scissors with the little handles there, and they're jointed here, that pair of scissors, these two sides, the edges of the scissors, are not going to change in length. But if I take that same pair of scissors and open it wider, again, this side and this side measure the same as this side and this side, but if this angle measure gets increased, then the distance between the tips of the scissors increases. And if I open the scissors really wide, even though these side lengths haven't changed, the distance of the third side is much larger as I increase this angle measure. So that's why they call it the hinge theorem. Okay, so let's talk about this, and what we're going to do, we're going to look at these two triangles, RSU and UTS, and we want to find the possible range of values for X. So I know a couple things about these two triangles. One, RU is congruent to UT, and sorry, they don't look congruent, but pretend they are. My drawing's not very good. I also know that US is congruent to US by the reflexive property. So the angle included between these two congruent pairs of angles will be dependent upon the side opposite them. So since this side is 10, ST, and RS is 15, I know that 60 degrees has to be greater than the angle measure 5x minus 20, because 60 is opposite the longer side. So knowing that, if I solve this inequality, 80 is greater than 5x, divide by 5, and x has to be less than 16. So x has to be less than 16 in order for this angle measure to remain smaller than 60 degrees. But I don't know what the bottom range of x is, so I'm going to use one other fact, which is that we know that 5x minus 20 has to be greater than 0 because it's an angle. So it has to be greater than 0. So 5x has to be greater than 0 and x has to be greater than 4. So now I know that x is greater than 4 and less than 16. So I'm going to write it this way. That's our compound inequality where x is between 4 and 16. So this section is also going to be a lot of algebra, and that's the only concept that we need to deal with today.